Are you clear now? Okay. So, and for you take out, right? You take out reaction, I will have solid, solid, you will break down to give you two different solids, S2 and S3. Okay? Now, typically, for synthetic, I hope you can bear with me. I'm struggling a bit. Okay. Now, synthetic, the phase diagram, we have to know how the phase diagram looks like. Okay? The phase diagram can look something like this. Okay? Alright? Okay? Can be. Okay? Alright. So here, what must be here? Temperature. And what must be here? Percentage. A. So here is 0, here will be what? 100%. Yes, for A and B. Right? Now, take a look at this. Up here is what? Liquid. Then I will put dotted lines. I will put dotted lines. Okay? Now, over this side, this side, you see this point here? This point here, this point here is known as the what? Synthetic point. Synthetic point. Over this side, my alloy will be known as hyposynthetic. And over this side, to the right, you will be known as hypersynthetic. And when the composition corresponds exactly to this point here, the alloy will be known as synthetic. Synthetic. Are you clear? Are you clear to this point? Okay? Alright. Now, here I will have got, okay, okay, here, this side here, I will have got liquid plus A, B of A, okay? And over this side here, I will get liquid plus B of B. Okay? Alright, so this one here is what? Here is 100% B, alright, no? 100% B. So here will be liquid plus B of B. Alright? This side here is 100% what? A. So this side here will be what? Liquid plus A is a solid. A is a solid. Are you clear now? Okay? Alright. Now, Can we have this? Okay, right? Okay, hypoeutatic, okay, hypoeutatic. If I were to make this alloy here, X, over this side here, it will be what? Hypoeutatic. So, at this point here, number one is what? All liquid. Are you all clear or not? This point here, it will start to solidify. So, this one here is the what? Liquidus. Remember, you did this in my first lecture with you. So, I will get what? More and more what? B being formed. Alright? Now, this line here is known as the what? This is a eutectic point. This line here is the what? Eutectic line. Are you clear or not? Okay. Now, from here to here, I will get P of B being formed. P of B being formed. Okay? P of B. Now, the B that is formed here, I can also call it primary B. Either I call it primary B or pro-eutectic B. That's the name. Okay? So, this one here, the B here is what? Primary or pro-eutectic B. Over this side here, the B. Okay? Alright, now, when I reach this line here, the eutectic line here, what happens? When I reach the eutectic line, eutectic reactions will take place. This is the what? Eutectic reaction. It will take place. Okay? My remaining liquid will solidify into what? A plus B. Because I got two solids here, A and B. Okay? This A plus B, when it is solidified together, it is known as a what? Eutectic mixture. Okay? So it is known as a what? Eutectic mixture. Okay? Eutectic mixture. So, what do I get here? At this point here, what do I get? I will get what? I will get A, no sorry, not A, B. Where's the B from? This part here. Okay? So it is known as what B? Primary or what? Pro-eutectic. Last, the remaining liquid, will solidify, okay, into under this reaction. So I will have a what? Primary B plus the what? The eutectic, okay, mixture. This is the eutectic mixture, A and B. Okay? Are you all clear with that? Alright, now, if I ask you the same thing, what do you get if you are over this side? Same. But you are getting what? Primary or pro-eutectic A. Is everybody clear? If I were to draw a line, okay, what do I get here at this point here? I will get what? Primary A, which is formed over here, plus the what? Eutectic mixture. And what is this eutectic mixture? When A and B solidify at the same time. Okay? Alright, now, can you tell me what will happen if I got exactly the eutectic composition? That means the eutectic point. So, for eutectic alloy, exactly eutectic composition. This is the eutectic composition. Okay, what do I get? This one will give me what? 100% what? Eutectic what? Mixture. Are you okay with that? Are you okay with that? Alright, now. There is if you see a phase diagram, which is like this, can you see all the way to the end? Okay, then it must give you beyond A or beyond B. Alright, now, supposing you have something like this. You have something like this. Okay? Over here is what? Solid solution. Remember solid solution? We talk about solid solution where you got solubility limit. This line here, you do your aluminum copper alloy. You got something like this, isn't it? Alright? So here is what? Liquid. So here is what? Liquid plus what? Alpha. Your solid solution. But over this side here, do you get a solid? Your solid, would it be what? Would it be a solid solution? No. It will be something like this. Okay? So if let's say, alright, I got 0. Here is 100% A. So here is mainly what? A. Correct or not? So I should be getting what? Over this side here should be what? Liquid plus what? A. Okay. Here I can get almost pure A here. And here not A. Alright? So everything else is the same. If in exam you get a phase diagram like this, then they ask you, okay, for this composition here, alright, I call it Y. Describe what happened as you pull down. Alright, it's the same, isn't it? Same as how you describe the Y, except here you will be getting what? Primary alpha instead of what? Primary A or B. Alright, the other side, I will be getting what? Beyond A. Okay? So this is the difference. Here, if you got this shape here, then this side here will be a what? The solid will be a what? Solid solution. Okay? Now, in this case here, what is your eutectic reaction? Tell me. What is your eutectic reaction? You see, this is your eutectic line, isn't it? Okay? So, again here, pro-eutectic. No, here is what? Hypo, then hyper. So, for eutectic reaction, I will get liquid, will give me what? Alpha and A at the same time. when this will be my what? Eustatic mixture. Okay, are you all clear with that? Alright? Now, what about eutectoid? How about eutectoid? The best one, eutectoid, is your iron-carbon diagram. You are all familiar with that, isn't it? Your iron-carbon, So, let's take the iron-carbon phase diagram, 0. I think here is 1.7. This is your percentage carbon. This one here 0.183%. And I have got something like this. Okay, something like this. Here it is what? This alpha is what? Ferrite. Ferrite. Okay? This one here is your what? Ferrite. And this point here is your eutectic point 0.8. Alright? And got something like this. Here is 910 degrees centigrade. This one here is I think 723 degrees centigrade, 0.8. This one is 11, I think it's 1194 degrees centigrade here, this point. Then this is 1.7% carbon. This is 0.8, this is 0. Okay? Now, over this one here, okay, I will have up here is what? Gamma is actually what? Austenite. And over here, this side here, I should be getting what? Plus alpha. So this alpha here that is formed here will be known as what? Primary or low eutectic, or no, not eutectic. Here is what? Eutectoid. So can we do one thing? What do you think we should do? What do you think we should do? This one here is what? Eutectoid. This one here is what? Hypereutectoid. And exactly 0.83 will be what? Eutectoid. Okay? So this one here will be what? Eutectoid. This is the what? Eutectoid point. This line here is a what? Eutectoid line. And what is your eutectoid reaction? Okay, this is your eutectoid reaction. In this case, okay, alright, what is your eutectoid reaction? It should be what? Gamma, which is your actually what? Austenite. Here is actually gamma plus Fe3C. Fe3C is the compound, not a solid solution, just like a pure material compound. Are you clear now? Okay, just like, you know, solid solution is you have one thing dissolved in another. The compound or pure metal will actually have this shape. Are you clear now? Okay, when you have got this shape, that means here was no solid solution. Alright, so this one is just like same as this. Either pure metal or compound will give you what? This shape. Okay? Alright, so over here, alright, what do you get? For hypo, for this one here, what do you get? What do you get? At room temperature, you will get what? You will get primary what? Primary or what? Pro-eutatic alpha, which is the ferrite, ferrite plus eutatic mixture. And what is your eutatic mixture? What is your eutatic mixture? It consists of what? S2, S3, that means this one here plus this one here. So your gamma will break down to give you what? Your ferrite and your cementite, same type. Okay? And this one here, ferrite and cementite, when they are formed by the eutectoid reaction, the mixture is known as what? Perlite. Have you come across that before? Perlite. So your eutectic mixture here actually is a what? Perlite. Okay? So for eutectoid, eutectoid, would I get primary ferrite or primary cementite? No. Can you see, this one here is just like this one here, it will be what? 100% what? Perlite. Okay? Only the mixture. So for eutectoid, okay, what do I get? I will get, for eutectoid composition, I will get what? Eutectoid steel, I will get 100% what? Perlite. 100% what? Perlite. Okay? Alright, now what about this side here? This side here. If I were to draw a line, what do I get at this point? For hyper-eutectoid, what do I get? I will get what? Cementite. And here primary cementite. And when I reach this line here, I will get what? This reaction. So I should be getting what? Primary or pro-eutectoid, cementite plus your what? Plus your perlite. Your eutectoid mixture actually is the perlite. Okay? Alright. A bit blur, some of you. Okay, I will repeat one more time. I will run through one more time. Eutectic reaction is this one here. Liquid give you what? Two solid at the same time. When do you get your eutectic reaction? When do you get it? You see, this is the system, the eutectic system. When you cool down, when your remaining liquid reach this eutectic line. Are you clear or not? From here to here, I will be getting primary or pro-eutectic B in this case. Over this case here, I'll be getting what? Primary or pro-eutectic A. Okay? And then when I reach this line here, the remaining liquid will undergo what? Eutectic reaction. Always remember this, eutectic line, eutectic reaction will take place. Okay? Alright, now, if I have got this diagram here. This is a eutectic point. If my composition is exactly same as equivalent to this eutectic point, then my alloy is a what? Eutectic alloy. Okay? Over this side here, it will be what? Hypoeutectic alloy. This side here will be what? Hypereutectic alloy. Is everybody clear with this? Alright? So when I see whichever it is, I already told you down here, this is what I get, primary B plus your eutectic mixture. Here primary A at room temperature. Okay, primary A plus your eutectic mixture. Exactly the eutectic alloy, I will get 100% what? Eutectic. No primary A or primary B. Only eutectic. Alright, because I don't have this or don't have that. Okay, now if I have got this shape, it means what? A and B is not a solid solution. Are you clear enough? Okay, if I use if I use a tie bar, can you see a tie bar? Over here, my solid is what? 100% what? B. Then this side here, I will have a what? You know, the liquid composition. Remember that how we use the tie bar? Same thing here, you see, if I use a tie bar, the solid here will be what? 100%. But if I have got this one here, and this one here, that means this part here represents a what? Solid solution. So if I use a tie bar, my solid is always what? Over here, composition of a what? Solid solution. Are you clear enough? So if I got this, my solid actually is a solid solution. And your phase diagram can be something like this one. One side solid solution, are you clear enough? The other side can be your metal or the compound. Now, if I have a eutectoid system, everything else is the same, except here I have got this reaction. The solid, when I reach the what? This line will be now known as the what? Eutectoid line. You will undergo what? The solid, remaining solid. In this case, the solid here, initial solid is S1. In this case here is what? Gamma. Alright? Will undergo this what? Eutectoid reaction. It will give me alpha and what? This one here. Cementite. This one here is what? Ferrite. This one here is cementite. Ferrite and cementite. When undergoes eutectoid reaction, come out at the same time. That would be the light. Okay, that will be the light. Okay, in steel, here I'm talking about what? Steel. Remember steel? When you do austenitizing, then after you cool down, your what? Austenite will change to what? Austenite will change to what? Change to light. Actually, reaction. Okay? Alright? Are you all clear with this? Okay, I'm going to show some of this. Okay, so this is eutectic, already explained. Is it here? Can you see here? This one here is what? Alpha and beta is actually solid solution in this case. You know, I showed you already just now. Alright? If it is straight down, then you'll either be pure A or a compound. Okay? So, the three different alloys, I have got what? Hypoeutectoid, hypoeutectic, eutectic, and what? Hypereutectic. I showed you. Okay. Okay. So are you okay with this? Are you okay with this? All right, now, next thing I want to deal with you is solvent line. Right? This one, you may need to understand this for your aluminum heat treatment. Okay, all right. Remember your aluminum copper system, ALCU alloy. Can you help me? Okay. This one is what percentage copper? If you look at your phase diagram, can you look at the aluminum copper phase diagram in your textbook? Can you tell me what temperature is this? This temperature is what temperature? Roughly? Sorry? Look at aluminum copper. I didn't open book exam die, man. Cannot find aluminum copper. Nobody found it yet.
Found it already.
How much? Roughly? Approximately will do.
Which one? The
Temperature.
for this part is 550 degrees Celsius.
550 degrees. This point about how much?
650.
650, and this point here? Roughly? How many percent copper?
Yeah, haven't reached yet.
Okay, more important is this one. Roughly?
4.8.
4.8.
8.
Okay. Okay, thank you. Never mind. Approximately will do lah. I think this is for illustration purpose lah. This one you don't know. Roughly how much?
They never reached the
Oh, never read. What about yours? Anyone read?
page 460.
Aluminum, copper, alloy, phase diagram. So there. Nobody have. Okay, doesn't matter. Doesn't matter. Okay. Right now, when you do what you call it in exam, okay.
So 33%.
Thank you.
33.2.
33,
0.2.
So, can you see? This will be the what? Here is what? Liquid. Here is what? Liquid plus what? Alpha. Okay. Here is what? Liquid plus no, sorry.
Alpha.
Wrong. This one is just what? This one here is just what? Alpha. Correct, huh? Okay. And then, okay, never mind, Okay, now, so here, this side here, will be the what? Will be the what? No, sorry. What? Hypoionic. Okay? And here will be what? This side here will be what? Hyperionic. eutectic, and exactly this one here will be the what? Eutectic. We have done this now. Just now. Alright? So, if I'm asked like this, very straightforward. Correct or not? Okay? Because, okay, by the way, can you help me further? Here is liquid plus what? This side. What is the solid here?
Ether.
Huh?
Ether.
Ether. You know what is ether? Ether is what? CuAl2. It's a compound. Alright, it's a compound. Alright, yeah, very good. Now, okay, so this one very straightforward. I will get liquid here, liquid plus what? Primary alpha. Okay, and then when I'm down here, I will have what? What do I get down here? I will get primary alpha, which is formed here. Okay, plus the what you call that? The eutectic. Eutectic mixture is actually alpha and theta. Can you see not? This one and this one form at the same time. In this case, your eutectic reaction is this one. Liquid gives me what? Alpha plus theta. Okay, this is your what? S2. This is your what? S1. You know, we say liquid must be what? S1 plus what? S2. Okay? Alright, now. But in your, what you call it, heat treatment, so here, because I've got alpha, usually in the phase diagram, they will just put what? Over this side, when you got hypoeutectic, they will just say you got alpha plus what? Theta. That's all correct, no? In a lot of books, they just put that. They don't separate out into detail like this. They just put alpha plus theta. Because can you see it? You got alpha here, and theta. So they just put like this. You'll see this in a lot of your books. Alright? Okay, now, what? So, this one very clear, you get, if I cool down, I will get what? Primary what? Alpha plus the what? Eutectic. Okay, now, what happens if you are over this side? This is your heat treatment, This is your heat treatment, you know? This side here. Can you see here you got 4.8, sorry. Okay, in your experiment, your aluminum copper alloy, your copper content is about 4% copper. Do you know that? Did you do the EDAC exercise to find out your copper? It's about what? Around what? Around 4%. That is for your experiment, you know. Okay, so you see this line here, this line here is known as the what? Solvers what? Line. Okay, solvers line, Solvers line stands for what? Represents the line that indicates your solubility limit. I want you to take note of this, okay? You see, this point here, alright? Below here will be what? Okay, below will be what? Saturated. Below the solvers line. Okay? Above here, this point here, above the line will be what? unsaturated. Meaning this solid solution is unsaturated. Okay, let's do this. Over here, what do I have? I have got alpha and what? Theta. Okay, theta contains what? Copper. Now, my alpha here is saturated. Okay, that's why the excess copper must come out. It will not come out as what? Pure copper, but it appears in the form of what? The copper compound. I repeat it again. Below here, my alpha is what? Saturated. When it is saturated, any excess copper has to come out. It will not come out as what? Pure copper. It will come out as what? Theta, which is the compound. Okay? Now, when I heat it up, above this solvent line, above it, it becomes what? Unsaturated. So what happens? The copper can dissolve to the solid solution. So can you see or not? Up here I only got alpha. But my alpha is what? Unsaturated. Okay? Alright. So this diagram here, you use it for your heat treatment. You know your heat treatment got two parts. What are the two parts? What are the two parts? Number one is what? Solution treatment. What do you do? What do you do? Solution treatment. What do you do? What do you do? You heat it up to this part here, isn't it? What temperature do you heat up to? In the length?
800.
Huh?
100 to 800.
You heat up to what temperature? Huh? What? 550. You see? 650 is here. 550, you heat up to 550. In the length? Cannot remember?
800.
Hey, 800, you die. I think, 500. 500? 450. 450 is also okay, no? Because 450 is already inside here. Alright, now the important thing is you must heat up to what? Above the what? Power slide. Okay, so in your solution treatment, okay, your alpha saturated plus theta will change to what? Alpha what? Unsaturated. Okay? That means you heat it up. Okay, it becomes what? Unsaturated. Can you remember this line here? Above it is unsaturated. Right? But what do you do? What do you do? You must what? Heat above solvers
Line.
and then what must you do? Quench. Remember this, you must what? Quench. Okay? You must quench up. When you quench, if I heat it up, then I let it cool very slowly. The slow cooling will allow what? Huh? Okay. This one here must quench, yeah. Okay. If above here, I want to cool it down slowly, yeah, then I will allow time for the what? The copper to come out as theta. That's why I need to quench. Are you all clear enough? That is why you quench. Okay, now this one here is what? Unstable. Alpha, sorry. Sorry. Oh, sorry. Okay, I beg your pardon. Yeah. Okay. I will do it two parts, then you don't get confused. When I hit it above, it becomes what? Unsaturated. Okay? Then alpha unsaturated. When you quench, what happens? It becomes what? Alpha super saturated. Okay, yeah. Listen here. Okay. When I heat it up, I will get what? Alpha what? Unsaturated. Then after that I quench. When I quench, okay, there is no time for the what? The theta to come out. It will remain in the solution. So the alpha is a what? Supersaturated solid solution. If I have got this one here, slow cooling, then it will allow the copper to come out. Then what I get will be what? I will get back to this one here. Okay, alpha saturated plus what? Theta. Okay, alright, but when we talk about solution treatment, you must not do what? Slow cooling. You must quench. Are you clear now? You must quench. Okay, everybody happy with this? Alright, what is the next part of your heat treatment? What is the next part? Part 2? Part 2 is what? Part 2 is what? Precipitation hardening. Okay, precipitation hardening is this. Alpha super saturated. Okay, you do what? Aging. When you do aging, you will get what? Alpha saturated.